happy to pay, you know, $20 billion between AT&T and Verizon for those networks, for access just to the spectrum. That's no infrastructure bill, that's nothing
Or
to do.
utilization.
Yeah, that utilization, optimization, right? So we're really talking about Metcalfe's law, right? And if you think about it from their perspective, that's kind of the core of the network, the spectrum, and then they build out from there. They want as many devices on this network as they humanly can, but they have to manage the consumer expectation. They don't even give preferential treatment to the federal government, right? So it's all going to be managed in a way that we can share this valuable spectrum together in a way that adds business value for everybody. And I think, you know, we have to align with that mission.
And competition will enter the space. I mean,
It will.
when it comes to where they're inhibiting you from growing your business, you will turn to other people will recognize your need and provide you with alternatives to that.
Well, there's not that many carriers, that's the problem. If there were 20.
That is true. It is capital intense business
Well,
to get into.
There are a variety of ways of addressing this. Certainly, in some cases, you're in the middle of, you know, Timbuktu, Utah, and there happens to be one cellular carrier out there, and there's no other wireless at all, and you want to be connected to the network for your M2M device, which is maybe measuring stream flow or something like that. Well, you don't have a lot of options at that point, unless you have access to a satellite, unless you have access to some kind of a private land mobile radio network that you can use as a backhaul method. So there are options. You just need to be more flexible when you start thinking about what those options might be. As well, you have to consider that protocols will be different, because traditionally the legacy networks that we do have available to us aren't necessarily all IP based. They're not all, you know, you don't get an Ethernet address and just be able to start communicating. So I think that, you know, it was touched on earlier that there's a lot of legacy stuff out there, and we can't just abandon it as we move forward. We have to figure out ways to not only look diligently towards the future and push towards a future where there's a lot more homogenization, but at the same time realize that we have a lot of infrastructure that's out there already today, which we need to take advantage of. We can't just abandon it. So this is a transition period where there is going to be, you know, wouldn't it be great if we could all have the same color tags on, but right now we don't. And so let's figure out a way to, at various levels in the food chain, how do we munge that data together and move it up to the next level and put the appropriate tags on it so that we understand what that means and we understand how it got to this point. But we appreciate the value that we got the data. So I think there's some great opportunities moving ahead, but it's not easy.
Yeah, one thing I'd like to add to that is take whatever forecast you want about how things get connected by 2016 and by 2020, right? So let's use the 2016 numbers right now. We have, as an industry, probably done disservice to the market opportunity in M2M by limiting it almost solely around the cellular dynamic. And M2M is really, I was just in a meeting with like 25 of the top 100 companies from the Connected World 100. And we were all talking about M2M and what should we call it going forward, because we're losing the value in M2M. And I was amazed at how many of those companies still characterize M2M as a cellular dynamic, right? We don't believe that at Intel. No matter, take your most optimistic forecast you want, at most 1 in 5 connections will be cellular in this space. So we've got to remember that there's a huge legacy twisted pair environment out here. There's a huge Ethernet and internet, and there's legacy network architectures, wide area networks like X25 and ISDN, and those are still all out there. You know, there's a lot of ways people are going to connect stuff, and I don't think we even appreciate yet how much work has got to get done to marry that network architecture and network topology to the diverse systems that are coming down the line, and cellular is but one of those answers. The network operators are figuring that out real fast, by the way, and one thing you should recognize is most of the cellular guys happen to also be the wired guys, right? And they're now linking those two things together. and they don't want to be relegated to being a dumb pipe. So you're starting to see the services dynamic change remarkably in all the operators, in the Verizons, the AT&Ts, the Deutsche Telecoms, and interesting partnerships are being built between cloud services and data center companies, and acquisitions are being made, notably Verizon that acquired Terramark and recently Hughes Telematics. So you're starting to see a big shift in what these operators are going to become, and I think they're going to be building vertical expertise and services differentiation. It's going to take them far beyond what they do as just a connected network business.
In the interest of time, I've seen these two hands come up here in the front. I'm going to take this question here from the gentleman in the brown jacket, and then Cyril, your question.
Thank you, Christine. Rick, a question for you. When's Intel going to address the missing void microcontrollers?
Great
Get back into
question.
the microcontroller business?
So I'll say stay tuned. I think it's going to be an exciting year. I really do. I think Intel is putting a lot of energy and effort into understanding. I mean, we did an executive briefing last year, so this isn't like new thinking. An executive briefing last year on what the demands are when you go into the sensor attach and you go down into the controller piece of the market and you start looking at embedded control below the edge. What our friends at Cisco call the fog. What happens below the cloud and in between the cloud and the sensor. We know there's a huge opportunity in that space to build really capable, analytics-aware, sensor-attached technology that will allow us to bring a deeper level of analytics to the network stack. And so there's a lot of work being done within the corporation, and I think the story, what I like telling our customers is, a lot of people tend to look at Intel and they get on the train at whatever station the train happens to be at, and they take that snapshot and they say, oh gee whiz, Intel's good, but, and then they look at all the stuff that's happening around it from the rest of the industry. If you put that Intel train in motion and you look what's going to happen between our manufacturing investments, the way we're moving our manufacturing nodes, the capabilities we're building around integrated systems, the power issues we're addressing, I think you're going to be, I think Intel's in a really good spot. And by the way, I'm saying this as a guy who's only been with the company for a year and a half, so I'm not one of those blue blood guys that's been drinking it so long I can't see the forest for the trees. I worked 22 years at Freescale and 7 years at AMD, so I got a pretty good appreciation of what's out there, and I think where Intel's headed is going to be pretty exciting.
Barry, both you and John have been shaking your heads. Do you want to add to anything that Rick has said? And then we'll take the gentleman in the front's question.
I wasn't shaking I was just agreeing.
Green, yes, no, shaking your head, yes, nodding your head. These are nodding your head.
Good.
Yeah, so I think there's a lot of alignment, and clearly you mentioned Flavio earlier, that clearly you know where we're headed, so I completely agree. And at some point you just get tired of hearing about Moore's Law, right? Eventually you want to talk about Metcalfe's Law or something else where you start to build out that architecture.
Right, so I keep asking the question, being new, I guess I can be a little bit of a renegade. Are you doing Moore's Law to say you can, or because you're going to make use of it?
Exactly.
Right, and I think you're going to be really amazed at where Intel's headed. It's a remarkable story internally.
What do you mean by that?
I'm not at liberty to discuss it
Moore's Law,
publicly.
How about,
Okay.
we'll come back, you guys can continue to have a discussion afterwards. I'd like to take the question from the
I'd like to
gentleman
go
in front.
back to the carriers and wireless connectivity for machine to machine. Well, I'm Alan Weisberger with the IEEE Communications Society, and a couple of years ago, we did a very well-attended workshop on machine to machine. And we had the head of both AT&T and Sprint's M2M division give us a talk. And both those companies feel that they can leverage their wireless networks, not only cellular, but also carrier-grade Wi-Fi as well as fixed WiMAX, with their purpose-built machine-to-machine platform. Now here's the rub. The rub is there's no standards for that, and each of those platforms is radically different in terms of provisioning, in terms of management, in terms of monitoring.
Certification, cost to
Right,
certify. all
right.
those other things.
And some of them communicate via software with control boxes, with residential gateways, and with the actual machine devices themselves. Has anything changed in 2 years? Because if this is actually the case, it becomes a situation where you have to do one machine-to-machine system for carrier A, and another for carrier B, and another for carrier C. And no one's gonna wanna do that. It'll create chaos.
But one
And
big
fracture the markets. I'm really interested in Cisco's approach, primarily because you deal with these carriers.
One big thing that's happened in the last 2 years, you mentioned Sprint, is they made a reversal of their decision, right? I mean, they basically collapsed on WiMAX. So, you know, to me, the big one was when Verizon made that decision, right? That was kind of what created the ecosystem we're
Actually,
all
that has
talking about.
nothing to do with my question. My question is not what's in the data plane for transport, but the fact that the provisioning, control, network management, and monitoring systems are different above the physical and MAC layer.
Right.
That was my question.
Yeah, so.
It doesn't matter whether it's Wi-Fi, WiMAX, LTE, that's irrelevant.
Right. Yeah,
So
so
it sounds like
the,
you're looking for an answer that addresses, so how do we span
Well, I'm
the
asking,
issues of
do
carriers?
the panelists see any progress in standardizing some of these carrier to controller or carrier to device functions? That's the
yeah, so
question.
one that I'm actually pretty impressed with is the way Deutsche Telekom is approaching it. And I think they're gonna be kind of the standard bearer on a lot of this stuff. You're right, there's a huge problem in that every time somebody architects a system and they go solder down a radio, they get into this massive certification, management, provisioning, distribution, set of issues they have to address, and it ends up being a huge cost burden